Welcome to Lesson 1, What is a Linear Relation? So here we'll look at how we can determine if a graph is linear and if a table of values is linear. So for a graph, if all the points lie in a straight line, then the relation is linear, like the graph on the left. All these points were plotted, and then they were able to be joined up in a straight line. Looking at the points on the right, they were not able to be joined up with the ruler as there's a slight curve to them, so we call that nonlinear. Now to see if a table of values is linear, we're going to see if there's a constant change in both the independent and dependent variables, and if there is, then it's linear. Now the x corresponds to all the independent values, and y values are all the dependent values. So this table of values on the left is considered linear since all of the independent values increase by 1. It goes from 3 to 4, then 4 to 5, and then 5 to 6. Now the dependent values increase by 6 each time. 16 to 22 is an increase of 6, and then 22 to 28, and 28 to 34. So because all the independent and dependent values increase by a constant amount, then it's linear. Now the table on the right, all of the independent values actually have a constant increase, 0, 1, 2, 3, but the dependent values do not. They go from 1 to 2, which is an increase of 1, but then 2 to 4, which is an increase of 2, and then 4 to 7, which is an increase of 3. So because the dependent values are not consistent in what they change by, then we call that nonlinear. So let's look at some examples. We have to determine which are linear and then state a reason for our choice. So A, we have a table of values. So let's look at the independent values first. See that increase by 10. 10 to 20, 20 to 30 is another increase of 10, and 30 to 40. Let's look at all the dependent values now. 2 to 4 is an increase of 2, 4 to 8 is an increase of 4, and 8 to 16 is an increase of 8. So because the dependent values do not change by the same amount each time, we call it nonlinear. So let's write down that this is nonlinear since there is not a constant change in the dependent variable. Okay, next one, we have a set of ordered pairs. So remember, ordered pairs are in the form x comma y. So we can write this in a table so we can easily see what the values increase or decrease by. So first we have 0, 23, 1, 18, 2, 13, 3, 8, and 4 and 3. Now looking at all of the independent values, they all increase by 1. Let's look at all the dependent. It goes from 23 to 18. So that's a decrease of 5. 18 to 13 is another decrease of 5. 13 to 8. And 8 to 3 is minus 5. So because there's a constant change in both independent and dependent, we're going to say it's linear. So I'll write down linear since there is a constant change in both the independent and dependent variables. Okay, and the last one here, we have a graph. So since all of these points here can be joined up with a ruler, and they all fall in a straight line here, we're going to say that this is linear. So it's linear since the points lie in a straight line.